So on the normal test, I just did 0 times whatever this comes out as equals 0. So I got it right, but I didn't figure it out correctly. I was supposed to use squeeze theorem. So here I use squeeze theorem, and sine x is in between -1 and 1. So e to the sine x over 3 is equal, in between e to the negative first and e to the first. So x times e to the sine x over 3 is in between x times e to the negative first and x times e to the first. And down here, the limit as x goes to 0 as e to the negative first equals 0, which is the same as x times e to the first. So therefore, by squeeze theorem, limit as x goes to 0 of x times e to the sine x over 3 equals 0. So for 3b on the actual test, I just plugged in 2 from the left, and I got a really small negative number on the bottom, and then whatever this comes out to would equal negative infinity, which is wrong. And so the correct way to do it is you get the u factor out the top part, and then these x minus 2's cancel, and then you have to put a negative in front of the kx minus 8. So that would come out as limit as x approaches 2 from the right is 8 minus kx. You plug 2 in for x, which is 8 minus 2k. So for 5a on the test, I did limit as x goes to 2 for f of x plus 3g of x. I just plugged in the closed points on the graph for f of x and g of x. So I got 1 plus 3 times 2 equals 7, which is incorrect because I didn't take the limit from the left and right of 2. So in the test corrections, I took the limit from the right, which came out to 8, took the limit from the left, which came out to 14, and so therefore limit as x approaches 2 for f of x plus 3g of x equals d and e. So for 6b on the test, I did f of x over x minus c. I took the limit from the right and the left. From the right, I got infinity, and from the left I got negative infinity, and this is because I did a parentheses. When I wrote it down, I wrote parentheses instead of absolute value, so that screwed up the whole problem. And so here on the test corrections, I wrote it correctly, and I took the limit from the right, which came out as 5 over c from the right minus c, which is 5 over a really small number, which equals infinity. And then I took the limit from the left, which is 5 over negative c minus c. Since it's an absolute value, this has to come out positive, and so that's a really small negative value with a negative in front of it, which comes out as a really small positive value, which is 5 over a really small positive value, which equals infinity. So therefore, limit as x approaches c for f of x of absolute value of x minus c equals infinity. So on the test, I put all the requirements onto the graph, so it looked something like this, with the holes here, the asymptotes here, and so what I did was, I guess I wasn't really thinking, so I just drew these lines right here, and I wanted it to be odd, so I reflected it across the origin, and so it came out like this. And at the time I wasn't really thinking like, oh, this isn't a function, so it's kind of what it came out as. And so on the corrections, I drew it like this, so it satisfies all the same the requirements. It's reflected across the origin. The limit is 4 here, the actual point's 2, goes to infinity up here, down here, and as x goes to negative infinity, the limit is 2, and it's reflected over the origin.